Hello everyone. My name is Valeria Gonzalez and today is Monday, August 24th. So I've never used this, so it's kind of like a new thing for me, so bear with me. But my name is Valeria Gonzalez and today I will be presenting my final disease cell project on the Menkes disease, and I'm going to be focusing on its cellular basis and etiology pathway and future therapeutic horizon. So here on slide number 2, here we go. Did it change? Yes. On slide number 2, we can see I'm gonna be talking about the introduction and overview. And to begin our overview in module 14, the deliverable number 1 establishes the clinical presentation and general background of this rare X-linked condition. And over here on slide number 3, we can see here, slide number 3. I just can't see the same thing as you guys can see on my screen. But this is a clinical presentation and the epidemiology, and the Menkes disease is frequently known as kinky hair syndrome and is a severe X-linked recessive genetic disorder that profoundly affects a systematic order. And the copper homeostasis. While infants are entirely asymptomatic at birth, they typically present a hallmark symptom at 2 or 3 months of age. And here in slide number 4, we can see the cellular etiology and genetics. And here for slide number 5, that we're going to be talking about the ATP7A gene mutation here. And we're also moving into deliverable number 2, where we examine the cellular etiology and genetics, and we're looking closely at genetics mutations and inheritance mechanisms. And Menkes disease is caused by deleterious mutations in the ATP7A gene located on the long arm of the X chromosome at the position XQ21.1. And approximately 70% of cases are inherited from heterozygous carrier mothers, while 30% arise from spontaneous de novo mutations. And that is because the human males possess only one X chromosome, and it's represented as X and Y. A single mutated gene copy is entirely sufficient to manifest full disease severity, whereas females possess 2 X chromosomes and are typically unaffected carriers. So that's usually how it goes on the ATP7A gene mutation. Going over on slide number 7, we are going to be talking about the pathology at the cellular level. Here we can see how the next deliverable explores the pathology at a cellular level and focusing especially on copper maldistribution and enzymatic failure. And here we go. It changed. Yes. The cellular copper maldistribution and enzyme inactivation, exactly. At the cellular level, enterocytes express mutated ATP7A, and it pumps that cannot export dietary copper into the bloodstream, and that is causing copper to become sequestered in the gut and kidneys, and this creates a state of symptomatic starvation in tissues requiring high copper concentrations like the brain, liver, and developing bones, and consequently crucial copper dependent enzymes like lysyl oxidase, cyclosome C oxidase, and dopamine beta hydroxyl, and they both lose their catalytic activity, destroying structural matrix integrity. And here we can see on this slide, which is slide number 9. And we're going to be talking about turning to deliverable number 4, where we evaluate the current treatment protocols and therapeutic frontiers. And here our current management relies heavily on copper histidine therapy. If I'm not wrong, that's how I pronounce it. I'm sorry, I've said before I have a language barrier and my first language is not English. And subcutaneously daily injections bypass the intestinal block, and this is raising serum levels and improving neurological outcomes. And if it initiates within the first 28 days of life, symptomatic management includes anti-seizure medications, nutritional support via enteral feeding tubes, and physical therapy. However, a major therapeutic barrier persists. Standard and subcutaneous copper supplemental fails to effectively cross the blood-brain barrier. And then one that is neurodegeneration, it's already established. And here on slide number 10, we are going to be talking about the cure on the horizon and the future research. And is there a cure on the horizon? I feel like current research is exploring 2 major pathways. First, the gene therapy innovations are investigating adeno-associated viral vector-mediated delivery to restore functional ATP7A expressions directly within the central nervous system tissues. And then the second, newborn screening initiatives using advanced plasma cathoshilorrhaphy and biomarker profiling aim to identify affected neonates immediately at birth. And this is ensuring copper histidine therapy begins before its irreversible neurodirection occurs. And now here are my references, and to support this presentation, a minimum of 5 resources were included, including primary literature by Dr. Stephen Keller and secondary professional overviews from the Cleveland Clinic, which is a major resource for me that I always use. And these were all utilized and cited in a strict APA format. Here, my image resource that I used on slide number 4, if I'm not wrong. This is my citation for it. Before turning this in, I'm going to be sure to include the picture so it's easier. But thank you so much, and this was my final presentation for this class. I really enjoyed it, and right now I'm currently in pharmacy school, and it's been a lot to handle this coursework while also doing pharmacy school. But my grades are due really soon, so I needed to finish this, and this is the last day to turn everything in. So thank you so much, Professor. I learned a lot in this class, and I really appreciate it. And that's it. I have no